All right, everybody, welcome to the first video of the new decade. The 2020s are here, and I'm really excited for them. You know, I'm done with the 2010s. The decade of doom is what I call it. The first part of the 2010s were okay for me because I was working with a company that was involved in the Olympics, so we were handling all the live sites, like all the events, like the after shows and stuff like that. So I had an insider perspective to a lot of the really fun stuff that was going on in the Olympics outside of the sporting events. And I'll never forget it. It was one of the best times of my life. Shortly after that, well, I'd say a few years after that, got the idea of getting a boat, and then picked up e-tolly and got onto that whole electric propulsion thing, which obviously I was still into, and I love that. So that was pretty cool. But the last part of the 2010s had a lot of personal things going on, a lot of like tumultuous things going on in my life, a lot of ups and downs, and yeah, I just like to put that all behind me. And then it also seemed in the last couple of years, it just seemed like everybody was willing to have their hair on fire for no reason at all. Like everyone was panicking over something, right? It was a really weird last couple of years. Just like everyone kind of was waking up angry, and I was like, dude, why are you so angry? Like, what's going on? Like, it's not that bad, you know? And but a lot of people just for some reason got into that, and it was starting to like wear on me. So I'm glad that the decade is over and we've got a new horizon ahead of us. I think the 20s are going to be similar to the 20s of the 1900s. We're going to have the same energy of the roaring 20s. Who knows? Maybe the Art Deco period will come back. And I'm just really excited for it. I think it's going to be a decade of positivity, and that's all I'm going to push here. For this video today, I'm going to do a brush check on the Lynch motor. So it's a really simple process. It's winter out. I'm not going to be doing any boating for a little while yet. As you can see behind me, it's not only snowing on the TV, but you can see that there's snow on the trees behind me. I woke up to a foot of snow. So I always just pull the motors out. Like I said before, it takes like 5 to 10 minutes to do this. You know, have them sit inside. You can check the motors over. And one of the main things you want to check is the brush life. So I'll show you how to do that. As you can see, I've got this one already apart, but I'll start it from the beginning, step by step, and I'll do that right now. Okay, so this is a pretty simple process. You're gonna need some gloves because you don't want to transfer any oil from your fingertips onto the brushes. You'll need an Allen key, small ruler, possibly a feeler gauge, and a little bit of sandpaper, but I'll get into that in a minute. I've already unbolted everything. I've got my 7 cap screws sitting right there, 3 of which hold the protective cover into place, and 4 which secure the brush holder in place like so. And you'll notice there's some spring action going on there, and that's to ensure that those brushes are pressed against the armature. So it's a Lynch motor, very unique design, one of a kind. Got the terminals here, power comes in, gets distributed down through these copper wires, down through the brushes, and onto the armature. Pop this off, and you've got your 8 individual brushes. I'm just going to move the motor out of the way because gives me a little bit more room for recording purposes. All right. So the first thing I do is I make sure, visually I can look at this just because I've done this before, and I already know that I've got lots of life left in these brushes, but I'll come back to that in a second. So what I'm going to do is just go through each individual brush and make sure that I've got some decent spring action. They all feel the same pretty much. Now what I want to keep an eye out for is anything that's binding. Because when you have something that's binding or rubbing, then you're not going to get the brushes to securely press against the armature. And if they bounce and if they're not connected properly, then you're going to get some unnecessary arcing. So you can see from the top how that looks when I press on them. And that's because there's a little spring inside this brush tube here. So the only one that feels a little bit different is this one here. You can even hear it. And I'll take that apart in a second just to double check there's nothing impeding the movement. I want to make sure there's no, maybe some dirt got in there, I'm not sure. But it definitely sounds different. Now, as far as movement goes, it's not It doesn't feel like it's going to be an issue, but we'll know when we take a closer look. Anyway, before I get into that, let's do a little brush measurement here. So you want to ensure that none of the brushes go below 1/4 of an inch or 5 to 6 millimeters. So I'll try to get this so that the light hits it properly. Now I measure from the top of the tube to the top of the brush. If you want to get really specific, you can pop the brush out and measure from the top of the rivet that holds the brush into place, and measure from the top of the rivet to the top of the brush. But when I measure from the top of the tube, it gives me a little bit extra margin. All right, so for example, I measure it like so, and that's a 1/2 inch. That's just over a 1/2 inch. That's just over a 1/2 inch. So these are all pretty good because I just want to make sure that it's not going below 1/4 of an inch. So you can even just visually tell that these are all fine. And that's pretty much it. All right, so let's get to the next step here. Well, actually, before I do that, the reason why I have a feeler gauge and a little bit of sandpaper out is just in case something was really binding up, like the brush looked like it had absorbed some unnecessary moisture, and it was binding when I was pressing it down and rubbing up against the tube. I could take the brush out, sand it down with a little sandpaper, like some fine sandpaper, and then when I put it back in, I want to make sure that I've got enough clearance between the brush and the tube, and that's 0.25 of a millimeter. So again, pretty straightforward process. Yeah. All right, let's take a look at that this guy here. See what's going on. Okay, so there's the brush. Pretty simple to remove. Just loosen the nut, slide her through the top of the tube, pop her out the other side. Unique design. There's the rivet I was mentioning. So if you really wanted to get meticulous about measuring the brush wear, you could pop these out and measure from the top. But for me, I just do it from the top of the tube. Unless you had a really thin ruler, you could maybe sneak it in there, but nonetheless, this is really good. Lots of life left in it. I don't know what is causing that racket inside the tube. So, I mean, this is how it would sit in the tube. So it's not going to catch on the sheath or anything like that. And there's definitely nothing that's obvious about why it would be making that noise. So just to show you the sheath, they sit above the tube line, so they don't interfere with the spring at all. So it's not that. Must be inside the tube. All right. Let's see if I can. Okay. This might be a little hard for you to see, but right away I can see that there are 2 little bumps on the inside of the tube. Okay, and okay, let me see if I can get this for the camera here. All right, so those 2 specks you see, that's light reflecting back, and those are 2, how can I position this? Anyway, you have to take my word for it. Those are 2 little bumps that look like they're actually part of the tube. So it's possible I can just take a file and file them down. But yeah, that's obviously what's happening, is that those little bumps are catching on the spring. And so when I push up and down, it's hopping over the coil. Now, it doesn't seem like it'd be too big of a deal because the brushes move inside the spring with no problem at all, but if it does cause it to jump, then that might be an issue because I don't want it to spark. You know, you want to have those brushes pressed up against the armature as securely as possible. Anyway, I'll get in touch with the manufacturer and I'll let you guys know where I net out with that. But I just wanted to show you how simple it is to actually do maintenance checks on these things. It really, it takes longer for me to record this on video than it would for me to actually do it. It really is, I would say honestly, the first initial inspection, if there wasn't that binding, you're looking at 10 minutes at tops, but because I had a little bit of a problem, it takes a little bit longer to get in there. So you're looking at, I don't know, maybe 20 minutes. And yeah, if these had absorbed moisture and they were thicker and they weren't sliding in the tubes properly, you could just sand it down like so. But yeah, there you go. All right, so this is just another point of interest here. This is the original core that came with the motor I'm doing the brush inspection on. Unfortunately, this met its fate a few years back. Just ran it too hard, overheated. Things started to melt. You can see all these little bits of solder here. Yeah, it was not a good day for it, but no big deal. Just bought a new one, replaced it. I keep it around because it's pretty unique. It's not your typical core windings you'd see in an electric motor. This uses copper strips, and yeah, at the end of these copper strips, you'll see another piece of metal. I believe that's copper as well, that caps off each end. Sandwiched in between the strips are pieces of iron ferrite. And yeah, this is where all the magic happens. So I'm not going to pretend to know anything about magnetic flux and all the voodoo that it produces, but just thought I'd show you what it looks like. It spins on a spindle like so, and the brushes press up against it, and voila, magic. I just keep it around because it's a topic of interest on occasion. Also doubles as a nice paperweight and a weapon, of course. Many uses. Anyway, there you be. All right, so as expected, there really wasn't an issue with those two little bumps. I emailed the guys, sent them a photo, just so that we're on the same page. They know what I'm talking about. And yeah, he's like, no big deal. You know what? Just take a little file, which I did, and file it down, and you should be good to go. And lo and behold, we're all good to go. Now, when you want to put this thing back together, it's really important that you pay attention to this mark here. I'm not sure what the newer ones are like because this is an older motor, so it did come with a mark on it here and a mark on the motor itself. So you want to make sure that when you put it all back together that that mark is lined up, because that is the neutral plane, and if you don't line that up, it's going to create a lot of sparking and some problems for you probably. Now, it is a really simple process, as I showed you, and if you do have an issue, the guys are very responsive, so you never really have to worry. One other thing that you want to keep in mind is brush replacement. Now, I've never had to do a brush replacement in 6 years, but I'm assuming sometime down the road I'm going to have to. Now, they're not cheap. They're about 25, 30 bucks, but it's not really a big deal because they last so long, and it's one of those you get what you pay for scenarios. I've had my motor for 6 years, and I've never had to replace a brush yet, so that should say something right there. Anyway, that's it. Really simple process. Just wanted to show you guys how to do that. And don't forget to subscribe and like the channel, because the more likes and subscriptions I get, the more I will be motivated to create different content for you guys. And hopefully it's entertaining on some level and informative on some level. And that's pretty much it. All right. Again, Happy New Year. Stay positive.